one, something to that effect. 6 questions. So let's briefly talk about solving one-step equations, because that's what your homework was on Thursday. On Thursday, you had, for instance, a question that might say 2x is equal to 10. On Devin's paper, guess what his paper, this was number 1, guess what his answer says? He gets got a 5. Right? Now, technically, that number is what makes this equation true. However, this is what you must put on your test quiz tomorrow, not test, quiz. Is everybody listening? Step number 1 is you show your work. Your work is this. Where's the x? What's attached to it? Okay. How is 2 attached to x? So what are we going to do to both sides? She's not here. 2 is attached to x by multiplication. How do we get rid of it? What do we do to both sides? Are you listening? I will not gleefully, not joyfully, but I will mark you wrong if you don't show your work. Go. You're going to write fraction bar 2. All right? If you're getting rid of it by subtraction, I better see minus 2, minus 2. Getting rid of it by addition, I better see plus 2 in a bar. Getting rid of it by multiplication, there better be dot 2. Then, underneath of that, once you cancel, you're going to write the answer. The answer is circle it, and you're done. Every question, right? This is how, I won't have to remind you this next year when you do more challenging ones, but that's how you solve an algebra problem. I got to see all the steps. I need the answer circled. Okay? Are we clear on that? No one tomorrow is just going to put 5. Like, wait, 5's the answer. Okay, yes, 5 is what makes the equation true, but I need to see the step that you did, and I need to see the final answer. And solve is always what value of the variable makes the equation true. In this case, x equals 5. All right. So, any questions on the homework before we grade it? Yes, Kylie.
I didn't understand 22 because
Was it a fraction?
you can be larger than
It is a fraction. So it says 18x is equal to 12. 18x is equal to 12. The nice thing about algebra is you just follow the rules. You don't even, it's almost like you don't even need to think. You just need to follow the rules. Where's x? What's attached to it? How is 18 attached to x? How do we get rid of multiplication? So what are we going to divide both sides by?
18.
So we write an 18, and whatever it says to do, we do it. 18 divided by 18 cancels. We're left with x is equal to, okay, it's not a friendly answer, it's a fraction. Reduce the fraction, don't sweat it. What goes into 12 and 18?
6.
6 goes into 12,
Wait, 2 times?
6 goes into 18,
3 times.
and there's your answer. Okay, it's not what we were expecting. We were expecting something like x equals 4. It's just a fraction. Danny got this on her test yesterday, and this caused her tremendous stress. She's like, but it's not what I'm thinking is going to happen. It's fine. It's just a fraction. It's okay. I think finally I convinced her, like, it's okay. Wasn't it literally this answer? It was something with a 3 underneath it, wasn't it? 7/3 or something like that? Okay. Yes.
Can we have a resource card on?
Always.
Okay.
On any test that I give, you can have a resource card.
Some places you can only have a resource card.
Yeah.
Some places.
No, I'm okay with it. All right, here we go. Now we're grading. Number 1, there's 28 of these, so we're going to do these quickly. Number 1, n equals 15. Number 2, n equals 29. Number 3, n equals 18. Number 4, n equals 5. Number 5, n equals 6. Number 6, n equals 32. Number 7, n equals 54. Number 8, n equals 30. Number 9, n equals 84. Number 10, n equals 60, 60. Number 11, n equals 28. Number 12, n equals 11. Apparently, I like the variable n. Number 13, n equals 5. Number 14, n equals 72. Number 15, n equals 10. Number 16, n equals 12. Number 17, n equals 91. Number 18, n equals 96. Number 19, n equals 11. Number 20, n equals 17. All right, now we come to the ones that we get fraction answers. Number 21, x equals 7.5. We just did 22 on the board. X equals 2/3. Number 23, x equals 221. Number 24, x equals 165. Number 25, x equals 252. Number 26, x equals 621. Number 27, x equals 5/6, 5/6. And 28, x equals 6 1/3. Yes.
Can you repeat 23?
221, 221. How many questions on the quiz tomorrow?
6.
6. All right. All right, Nelius is coming around to grab that. Good news, bad news. The good news is we are doing nothing new today. However, bad news is we're going to do the same thing we did on Thursday, except with decimals and fractions.
No.
So your homework for tonight. Your homework for tonight is as follows. Oh, everyone look at the calendar real quick. Quiz tomorrow. MLK on Monday. So we got 3-day weekend. Yahoo. We got test a long time from now. So am I. Where are you going? Oh, I thought I said I'm going golfing. Oh, heck yeah, I'm going golf. I'm going golfing Saturday and Monday.
Where are you going?
Saturday I'm going to Valley, and then Monday or Saturday Valley, and then Monday we're going to Canyon City. There's a place called 4 Mile. It's awesome golf course.
I thought you were talking about wow.
All right, homework. Here it is.
Homework! Yay!
Hey, on Thursday I gave you questions 1 through 28 all. I'm not giving you 1 through 28 all. Guess why? All of these involve very ugly numbers. It will take you time to get to answers for all of these. So you don't need to do 28 of these because you already did the hard work on the 28 of those. Now you should be experts at one-step equations. Now we're just seeing one-step equations where the numbers involved are not nice. It's going to involve decimal long division. It's going to involve decimal multiplication, decimal addition, decimal subtraction, and fractional add, subtract, multiply, and divide. Okay. Yes, you may. I'm going to have to start charging for pencils. Usually I charge either 10 push-ups or 25 cents.
I'll give you 25.
And I only give away quality pencils too.
Well, they're not crappy.
Well, there's only one good pencil, and that's Ticonderoga. They're very nice.
Number 2. Will you give us that away? The difference between number 1 and number 2.
All right. So here's the deal. If you already know how to do add, subtract, multiply, and divide, and you're very confident with decimals and fractions, it's just a one-step equation. Do exactly what we did before. However, I do realize by 7th grade, I still have occasionally some kids that still struggle a little bit with add, subtract, multiply, and divide with fractions and decimals. Now, last chapter was all about fractions, so I'm going to choose not to do too many of those. I'm going to choose to show you more examples involving decimals. Okay? All right, here we go. So it's just a one-step equation involving fractions and decimals. All right. We're going to do everything. Add, subtract, multiply, and divide all in one class. All right. Here is what the quiz will look like tomorrow. Everyone look at the board. I said 6 questions. Well, here's 4 of them, right? Hey, what are you going to do upper left? What are you going to do to both sides?
Divide by 2.
What are we going to do bottom left?
Subtract by 2.
Make sure everyone's listening and watching. What are we doing to both sides?
Subtract by 2.
Upper right?
Divide by 2.
Oh, absolutely not. Multiply by 2. And then the lower right,
Divide by 2.
add 2 to both sides. I thought I heard most of you saying the right answers. Hey, if you look at the board right now, or if you're like Nathan, who was not looking at anything, right? When I say this is what's going to be on the quiz, that's keywords of, man, maybe I should pay attention right now. So I'll give you these 4 different, slightly different numbers. Not much different. I don't have to make the numbers that much more challenging to see if you know how to do it. You got to show the work. You just write the first one, oh, x is equal to 6, then I'm going to mark you wrong because you didn't show me how to do the algebra problem. Remember, right after this, like literally tomorrow's class is going to be on 2-step equations. All right, which I saw a whole bunch of those on the test yesterday. I also saw, who was it? Was it Caden? Was it you? He had one that involved negative numbers, and we were like, well, how do we do this? And, okay, we didn't have much chance with the negative number ones, but the positive ones you should have been able to solve. So all these involve nice, friendly whole numbers. Today, we will not be doing friendly numbers. We'll be doing the unfriendly numbers, the decimals and the fractions. Okay, so here we go. Example like this. The process is still the same. Hey, variables on the left side. What's attached to it?
2.1.
How is it attached?
Multiplication.
How do you get rid of multiplication? So we're going to divide both sides by 2.1. Hey, what are we going to do to both sides? Is everybody participating here? Right? What are we going to do to both sides? Subtract 2.1. Right? So that's how it's going to look with decimals. Now I want to show you 2, but remember there's 4 things you can be doing. Then we'll do the same thing with fractions. Hey, what are we going to do to both sides here? By. Okay. What are we going to do to both sides here? Oh no, 2/3 is positive. Let's subtract 2/3 from both sides. No. How do you get rid of 2/3? Right? You're going to subtract 2/3 from both sides. Okay? All right. So here we go. I'm going to choose to do more decimals than fractions because last chapter was all on fractions. Here we go. You said x is on the left side, attached by 2.1 by multiplication. Therefore, we're going to, Madison, both sides by okay, both sides by 2.1. Tomorrow in the quiz, I want to see a fraction bar. Right? 2.1 divided by 2.1. It's not 0. Right? We say cancel. Cancel means, Madison was doing this to me, right? With the correct finger. Is 1. Okay? That red line there, yeah, it does mean it slashes through and it goes away, but it doesn't mean 0. It means 1. Because 1 times x is, that's why we do that, slash. It means 1 times x is x. Uh-oh, problem. What's the problem? Decimal long division. Okay, do you remember how I explained this? Way back, I don't know, chapter 3 or 4? There's a tree. What do we do to the tree? It falls to the right because right is always correct, right? So it falls to the right. What falls on the inside? 12.6 or 2.1? Okay. As we do that tree, all right, if that works for you, it falls down, 12.6 falls on the inside. That's your dividend, and your divisor is 2.1. Okay. Quotient is your answer. Okay. Yes, I will insult your intelligence because some of you need it. I don't care about the dividend. Like how many decimal places. Don't care. I'm going to do something to it, but I don't care whether there's 1, 5, or no decimal places. I only care about the divisor. How many decimal places? So I need to move it once. Not because this one, the dividend has 1, but because the divisor has 1. The dividend can have 14 decimal places. I still would only move it once. The divisor right here controls everything. I move that one place. I move that one place. My recommendation right now is to move that new decimal place immediately to the top. Straight up. Put it there. Now we don't have to worry about it. Okay, now comes the problem which most of you have, or some of you have, right? I don't know what numbers to pick. So here's my word of advice. Don't think of this as 21. Think of this as 20. You got to be careful when you're writing. Now 20 is nice because it's only one away. If it was 24, or sorry, 23, and you round it to 25 or something like that, it's a lot of rounding going on there. Okay, but yeah, we're gonna think of this as 20. Does 20 go into 1? So we put a 0 or a dash or nothing. Does 20 go into 12? Put a 0, a dash, or nothing. Does 20 go into 120? How many times? I can count by 20s. 20, 40, 60, 80, 100, 120. 6 times. That's my guess. Not guaranteed to be the right answer. It's just a guess. It's a good guess, though. Okay? But it's your starting point. Remember the rules for long division. You take a guess, right? And when you do the multiplication, you get a number that's bigger than the dividend. You guess too high, make that 6 a 5. If after you do subtraction, you wind up with a number that's 21 or bigger, then you guess too small, make the 6 into a 7. You got to keep that in the back of mind. The long division is there's somewhat of a guess. This time we made a good guess because when you do the math, you find out you made the right guess. The reason why we move the decimal place before we do any of this is because now when you get to your final answer, there's no wait. Moving the decimal place, right? It's already there. The answer is 6. Now this is an algebra problem, so Laura, the final answer is wrong. So the final answer is you have to remember you're solving an algebra problem. So it must be in the form of whatever the variable is equals that number. Okay? All right. How long is it going to take you to do this? It'll take you a while. That's why you don't have 28 of these, Nathan. All right. So what really changes? Like, is anything that we did differently from solving a normal equation? It stays the same. Clearly, there's more work to do when there's decimals involved, right? That's the pain. The pain is you got to do decimal long division. You can't do some, 10 divided by 2 is 5, right? You're going to have to do scratch work. I would prefer the scratch work is away from the problem, but don't show me the work. This isn't going to be on the quiz tomorrow, but when you do this for the test, don't show me the work on page 3, right? Put it right next to the question so I can see it, but don't put it right here all in the way of your answer. Okay, ready to do one? All right, she's not. All right, but hopefully you are. Here we go. Box 1, here we go. Box 1, box 1, box 1. Grab your pencils, let's go. Hey, where's the X, left or right? What's attached to it? How's it attached? How do we get rid of multiplication? So what are we going to divide both sides by? Richard, grab your pencil, get working. All right, we're going to divide both sides by 0.42. 0.42. Oh, by the way, yes, I will embarrass her. Although one person hasn't finished their test, but they're not here in class right now. Natalie got the highest score. Good job, Natalie. What? Sam hasn't finished her. I'm going to guess that Natalie's still going to score higher than Sam. All right. I'll say I saw no surprises, like none. Right? You did okay. Right. Well, I'm going to individually talk to you, but not today. All right. I did want to recognize the student that got the highest score. All right. Second highest score was, I don't remember. I don't remember. It was Carson.
Who got the lowest score?
Okay, no, we're not going there. All right.
It was me. Can you tell me?
Here we go. Cut your tree down. As you chop your tree down, the 105 or the 1.05 goes on the inside. Remember, the tree falls to the right. Right is correct. 105 falls on the inside. The divisor is the denominator, 0.42. Nathan, you doing this or you drawing pictures? Let's do this. Okay. Well, then you could have said, yes, I'm doing this. Well, when I asked the question, I didn't hear an answer. All right. Hey, we do not care about the dividend. We only care about how many decimal places are in the divisor. How many decimal places? So we're going to move the dividend 2 places as well, too. So we move the divisor 2 places. We move the dividend 2 places. Laura, you already got the fire razor?
No.
Okay. You can move your desk a little bit.
right there.
No, you, Laura, Maddie, you can just move your desk a little bit. If his head's in the way, just move your desk a little bit. So his head's not in the way.
Or just tell him to.
Because he can't tell if his head's in the way.
Just ask him to move his big head.
All right, here we go. This now becomes 105, and this now becomes 42. So the problem, once again, is generally some kids can't think of 42 and 105. So make the math easier. Don't think of 42, think of,
84.
there's no 84 up here. And please don't be a smart aleck.
80.
Where do you see an 80?
No, you round the 42 to 0.40. 0.40.
There's no 0.40, it's 42. We just moved the decimal place.
Then round it to 40.
The 40. Okay? You can count by 40s really easy. Look, fingers. 40.
80.
120 is way bigger than 105, so how many times? Twice. When I run into kids that can't do decimal long division, it's this step right here that they're stuck on. Like, well, I don't know what, okay, I can move a decimal place, great, but then I don't know what to do. You round this divisor to a friendly number. It's not guaranteed to give you the right answer, but it's guaranteed to give you a close answer that you can quickly modify. I'm going to change 42 to 40, and I'm going to think about how many times is 40 going to 105? Well, 2 times. Goes into 1 0 times. It goes into 10 0 times. Some teachers have you put dashes. I like zeros. 40 goes into 105 2 times. Then I do the math. 2 times 4 is 8. 2 times 2 is 4. Sorry. 2 times 4 is 8. Do your subtraction. 4 from 5 is 1. I can't do 8 from 0, so I borrow from 1. That becomes a 10. 8 from 10 is a 2. I get 21. Okay, done with that step, bring down to 0. Notice I keep things nice and neat. For those of you that need graph paper to keep things nice and neat, do this on graph paper. Once again, I'm not going to think 42. I can't count by 42 times 8. I got to think about. 8 times 40 is 320. It's easy to think about. 8 times 4. So I'm thinking of 40 and 210. All right. How many times does 40 go into 210? Count by 40s. 40, 80, 120, 160, 200. So it went 5 times. 5 times 2 is 10. 0 carry your 1. 5 times 4 is 20 plus 1 is 21. Hey, remainder 0. We're done. Whatever's up there, I don't have to worry about decimal places. I just read it. Nathan, what's the final answer? Not 25. All right. All right. Now, I'm going to go back to the original question. Is anything different than when the numbers are friendly? The math is still the same, but clearly there's a heck of a lot more work. Okay? That's why you don't have 28 of these. All right. Question of solving things through division with decimals. All right. Do this one all by yourself, box 2. All by yourself, box 2. Is everyone okay to get started? All by yourself. Richard, grab your pencil, get this one done. Jake, get started. There's a decimal, 0.2. Oh, for the dividend. Well, there's always a decimal. We just choose not to write 6 as 6 point. You still got to move it over, so you got to add 0. Right? Correct.
Question I was going to ask, like, so we just had a 0 now?
You do. It is easy. It's just more work. David, you okay? Madison, already got the answer?
I don't know. Did I get this right?
We're going to find out here in a second. All right, let's see what we got here. Let's see, we get rid of multiplication by dividing. We divide both sides by 0.2. Okay. 0.2 divided by 0.2, that cancels. 1 times x is x. We gotta do some decimal long division. Chop the tree down. 6 falls to the inside, 0.2 on the outside. We got to move it 1 decimal place. This is the question everybody asks. Well, where's the, yeah, remember it's 6.0. Okay. So if we move it 1 decimal place, it's no longer 6.0, it's 60. We moved it 1 decimal place. Is everybody okay with that? Decimal, move to the top so you don't forget this. Okay, this one's easy. Hey, it's now 2. Does 2 go into 6? How many times? We put a 3 right above the 6 because that's what we're saying. 2 does go into 6. Remember the ones before, 2 didn't, or 20 didn't go into 6. But now it's a 2. 2 does go into 6 3 times. 3 times 2 is 6. Here's where you'll make your mistake. You see the decimal place? There's a spot right here that's nothing in it. You can't just leave an empty spot. You got to put a number there. Right? 6 minus 6 is 0. So what you're really saying is after you do your subtraction is how many times does 2 go into 0? It goes 0 times. Okay? So our final answer is not 30. X equals 30. Six minus 6 is 0. Okay? Bring down your 0. How many times does 2 go into 0? And that's why there's an extra 0 there. All right, you can't leave an empty spot. This one, and I always use this as an example because I have plenty of kids. Like, oh, no, 2 goes into 6 3 times, and they write 3. Right? You have to fill in all the spots. Okay? All right. Box 3 all by yourself. Go. Box 3 all by yourself. Laura, we're on box 3. Okay. Not with a calculator, by hand. So when I walk your paper, I'm going to see the scratch work. Yes? Open up your math book and start your homework. Richard, you got the answer? And you've got all the steps. All right, for those of you struggling, let me get started for you. Get rid of 0.28 by dividing because you get rid of multiplication by division. 0.28 on the left side cancels. On the right side, we got decimal long division. Chop the tree down. The 2.24 winds up on the inside, 0.28 on the outside. We don't care about the dividend. We care about the divisor, the number on the outside, how many decimal places. It has 2. So we move both the dividend and divisor 2 places. Straight to the top. All right, Caitlin, that number isn't 28. We're going to think about, instead of 28, we're going to think of 30. I can't count by 28s easily. I can go 28, 56, and then I stop. You rounded it to? Yes, that's what I would do. Because we can count by 30, 30, 60, 90, 120, 150, 180, 210. You can do that very easy. So I'm thinking of 30 instead of 28. 30 doesn't go into 2, so we put a 0. 30 doesn't go into 22, so we put a 0. But 30 does go into 224. Goes in 8 times. Our initial guess would be 7, right? We counted by 30s. So our initial guess would probably be 7. Watch what happens when we do it by 7. 7 times 8 is 56, carry your 5. 7 times 2 is 14, plus 5 is 19. When I do that subtraction, I get 28. When you do your subtraction, you get a number either bigger than the dividend or equal to the dividend. You increase your guess by 1. Okay? So here's an example of when I said, yeah, let's round, let's make a guess. Your guess is technically wrong, but it's only ever going to be wrong by 1. Right? And this is a whole lot easier than literally, which is why I saw Laura and Grace grabbing for a calculator. Right? Because they can't do 28. They're like, well, I don't know how many times 28 goes in there. That's the whole purpose of being able to do this without a calculator. So you got to have a technique. And it's not, well, where's the calculator? It's let's do a little bit of easy rounding. Okay? So it ends up going perfectly 8 times, and it works out great. Okay? Yeah, there's going to be ones like, sometimes it might go, I don't think you ever get I can look at the answers here in a second. You're not going to go like 18 decimal places, right?
Are we gonna do any repeats?
I don't know. I'll check before the end of class. Okay, are we good on this? So that's getting rid of a number attached to a variable through division. What's the opposite of that? Let's do one with multiplication. Okay. All right. Yes, you are correct. So we just did the hardest of the hard. Now we're going to do medium, right? One thing we will not do is adding, subtracting. I chose not to review adding, subtracting with decimals. Remember, when you add and subtract with decimals, you must line up the decimal place. Not true with multiplication. Okay, what's attached to x on this one? What's attached to x?
1.3.
What?
Oh, wait, I'm sorry. For you?
All right. How is 0.4 attached to x? How do we get rid of division? What are we going to multiply both sides by? That's how it is written. We're going to multiply both sides by 0.4. Okay. What's 0.4 divided by 0.4? 1. It's not 0, right? When you do adding or subtracting is when you get a 0. When you do multiplying or dividing, you don't ever get a 0. You get a 1 when you cancel. Okay. That red slash means 1. 1 times x is x. Okay. What's 2 times 3? What's 2 times 3? Don't overthink this. What's 3 times 2? Multiplication, watch me, is commutative. It doesn't matter the order that you multiply them. When you're multiplying with decimals, if you want to make your life easier, you should always put the one with the most digits on the top or bottom. Always put the one with the most digits on the top. It doesn't matter which one we write first. It does matter for subtraction. It does matter for division. It doesn't matter what adding or subtract or adding or multiplying. Put the one with the most digits on top. Hey, how many digits?
2.
How many digits?
2.
So does it matter which one goes on top? Tonight for homework, you might have one that has different number of digits. If you put the one with 3 on the bottom and one with 2 on the top, you're going to have 3 lines of multiplication. You put the one on top, you only have 2 lines. That's a whole lot easier. All right, so this one doesn't matter. It also doesn't matter to line up the decimal places. We don't, for multiplication, Nathan, you're really starting to tick me off. Then stop. You both have that capability. Just stop. When you're multiplying, it doesn't matter where the decimal places go. You worry about the decimal places at the final answer. Adding, subtracting, it matters. Dividing, it matters. Multiplying, it doesn't matter until the final step. We just do the multiplication algorithm from right to left. 4 times 7 is 28. So 8 carry 2. 4 times 1 is 4 plus 2 is 6. The other number is 0, so we don't need to do another line. Yeah.
On the test, are we going to have?
There's no decimals or fractions on the test tomorrow, quiz tomorrow. But there will be on the chapter test.
Yeah.
So what's your question?
That was my question.
All right. Then we count how many decimal places. How many total do we have here, Jake? Decimal places?
11.
Take a deep breath. Right? How many decimal places are here? So we move it 2 decimal places, and the final answer with a leading 0 will be 0.68 with an x. Don't forget your x. Okay, x equals 0.68.
How'd you get 0.68?
We got 68. There are 1, 2 decimal places. For multiplication, remember we always move it from right to left. So we move it 2 decimal places to the left.
Oh, I was doing the
Well, that's why, yeah. All right. Box 4, let's do it together. Grab your pencils if you don't already have it done. If you already have it done, check your work. Here we go. Hey, x is on the left side. What's attached to it? 1.3. How's 1.3 attached to x? We get rid of division by, we're going to multiply both sides by. Why am I teaching you algebra? Is because when you get to ugly numbers, you can't look at it and tell me the answer. You have to do the math. On the left side, the 1.3's cancel. On the right side, we got to do some multiplying with decimals. Put the one with the most digits on the top. They both have 2, so it doesn't make a difference. Hey, let's have Madison.
He has a piece of gum on
And-
his pencil in his desk.
Because it was in the desk.
Right.
What
Let's
is it? I
have
need that pencil.
Madison.
What?
For right now, I want you to sit right there.
Where?
I'm gonna come up with a better. I'm gonna have a better solution for tomorrow. But for right now, move right there, please.
Where?
The open seat right there. All right, 2.4 on the top, 1.3 on the bottom. And then do the multiplication algorithm. 3 times 4 is, okay, so 2 carry your 1. 3 times 2 is plus 1. Bring down a 0. 1 times 4. 1 times 2. Okay. We get 2. Okay. I'm going from right to left, not left to right. So we get a 2. 11. So 1 carry your 1. 2 plus 1 is 3. So we get 3, 1, 2. It's what Devin said. Okay. Questions? Oh, by the way, that's not the answer. What's the answer? We can't forget to move the decimal. That's not the answer either. What's the answer?
X equals 31.
Say it again.
X equals 31.
There you go. Now, if we said that correctly, we'd say x is equal to 3 and,
1200.
or we could say 3.12. Either one is fine. Okay. 3 and 1200ths or 3.12. Okay. We okay? Okay.
Like, for the
Multiplication, we don't drop the decimal straight down. Doesn't wind up there. It's how many decimal places there are. There's 1, 2 decimal places, so 1, 2. Okay. And it's always from right to left. All right, box 5. I'll give you a 10-second head start. Go. Richard, right. Fractions are next. Fractions are actually the easiest of them all, which is why I left them at the end. It doesn't look like they're the easiest, but they're actually the easiest. Yeah, that's like really easy. All right, here we go. Let's see. X on top, 1.8 on the bottom. 1.8 is attached by division. We get rid of division by multiplication. Multiply both sides by 1.8. 1.8 cancel. Let's see. I got two digits. Doesn't matter which one goes on top. I don't care about lining up the decimal places. I just put the one with the most digits on the top, one with the least on the bottom, and I do the multiplication algorithm. 8 times 9 is 72. So a 2 carry your 7. 8 times 2 is 16. Plus 7 is 23. Bring down to 0. 1 times 9 is 9. 1 times 2 is 2. And then we add 2, 2, 5. Wait, where did I get a 5 from? Well, 2 plus 0 is 2. 9 plus 3 is 12. So 2 carry your 1. 2 plus 2 is 4. Plus 1 is 5. That's not the answer because we got to move the decimal place 2 places. So 5.22. And that's still not the answer because it's an algebra problem. Nathan, the final answer is? Wrong. What's the final answer? Okay, have I made it clear, right? Because I'm picking on Nathan, because he did it twice now. You got to put an X in front, or whatever the variable is, right? It's an algebra problem. Yeah, 2.9 times 1.8 is 5.2. He's right on that, but that's not the final answer. The final answer is writing it in the form of, well, what's the solution? Danny?
So like we have that problem, but like after the equal sign, like when you just first do the problem, it's like has no decimal places.
Mhm.
Would we put the decimal from the fraction on?
Well, let's just imagine this was 29 instead of that. Then all you would do is move it 1 decimal place. So it would be 52.2. Basically the same thing, right? All right. I had one for you to do all by yourself. Yes, or for practice, or no for practice?
No. Yes.
All right, Nathan says yes, let's do it. All right, all by yourself, box 6. All by yourself. Anybody struggling out there? You need me to help you? And I'm going to repeat myself, broken record. You got the answer? Then do it. Macy worked.
I have it.
Oh,
I have the
wow.
answer.
impressive. You did it without a calculator,
Can I walk this through?
I didn't get it. I did all.
except for the fraction ones, right? That's the very next thing. The next thing we do is fraction. We're done.
All of them without. I did all these with.
Now put your mask on. Richard, mask. Ava, mask. Madison, mask. Nathan, mask. I wish I got to wear a mask when I was your age.
You wish?
Why?
Why?
Kids come to school with a mask, and what does the teacher normally say? Take off that mask. What do you think you are? Now we're letting you wear a mask.
You're making.
You have to wear masks.
That's what life is all about. Everybody wants to do it when you're not forced to. As soon as you're forced to it, nobody wants to do it.
I didn't.
I can go to sleep in your class now.
All right, let's see. We got to multiply both sides by 2.6. Talk me through. Go ahead, Macy. Go.
Yay. Okay. And then we do times with
Tell me what to do.
oh yeah 6 times 7
Is
42
2 carry 4. 6 times 3
18
plus 4 is 22. Bring down to 0. 2 times 7.
40
4 carry 1. I'm running out of spaces with my carrying here. 2 times 3 is 6 plus 1 is 7. Then we add, let's see, that would be 2, 6, 9. How many decimal places?
7
So final answer is?
9 x equals 9.62
All right, on to the more challenging stuff. All right. Look at the board. This is not an equation. This is an expression, no equal sign. Hey, here's the magic. You ready? Do you see the x?
Yeah.
You see the number attached to x? Watch what happens if I take that fraction and I flip it. I take that fraction and I flip it and put a multiplication symbol. Watch what happens. What's 3 divided by 3? What's 2 divided by 2? It all cancels. So, backing up, if you have a number attached to a variable and that number is a fraction, guess what you're going to multiply by? The fraction flips. I'll say that again. If you have a variable and a fraction, not decimal, and a fraction attached to a variable, you take that fraction, you flip it. That's what you multiply by to make it go away. Guess what you really just did? You just did division. When you divide with a fraction, that's the same as copy, dot, flip. So, yes, what's attached to the variable? 2/3. What's attached by multiplication? How do you get rid of multiplication? So, division with fraction is a copy, dot, flip. What are you copying? What's originally there. What are you flipping? What's originally there. Do you see what I did? That construction is what makes the fraction go away. What? Okay. The whole day? Go to the office. Yes.
oh so that would just leave us with the answer.
Well, I just wanted to show you this one little tiny piece part first. Okay? So now let's look at what it would look like if you had an equation. Everybody look at the board. Now it's an equation, not an expression. But check it out. Here's your x, and what's attached to it? A fraction. What did we literally just find out? That if we flip this fraction and do multiplication, it will make it go away. What are you really doing? How do you get rid of multiplication division? You're dividing by a fraction. Dividing by a fraction is a copy, dot, flip. So I'm going to copy this. I'm not going to flip that. I'm going to flip this. So you're copying and flipping the same thing. That's why some kids find this a little bit troubling. I'm copying and flipping the same thing. I'm copying the 3/4 and I'm flipping it. If I'm flipping it, I'm multiplying by 4/3 both sides. See what I did there? Both sides. I never flip what's on the other side of the equation symbol. The only thing I flip is what's attached to the x, but then I do that to both sides. Okay? Hey, what's 4 divided by 4? What's 3 divided by 3? It all cancels on that side. On this side, what do I do with the 15?
By, by,
What do I do with the 15?
I don't know.
Put it over 1. Can you do any cross reduction?
Yes.
Which one?
The 15.
3 and the 15, we can cross reduce. 3 goes into 3 how many times? 3 goes into 15 how many times? 5 times 4? We're going to do one nice and slow together. What's up?
So, you take the second fraction and put it next to the 15?
We always take the fraction that's attached to the x. And that's what we flip, and that's what we multiply by.
So the ones that we flip.
Correct. All right. 5 times 4 is, therefore, x equals
20.
All right. Now we're going to do it nice and slow. You ready? This is box number 7, the one that half of you are like, I don't know what to do here. Here we go. You see the x? Is it a decimal or a fraction attached to it? Is it a decimal or a fraction? It's a fraction. When there's a fraction attached to the variable, then we take that fraction and we multiply both sides by what you just flipped. What did we just flip? What did we just flip? So it turns into 8/1. That's what we're going to multiply both sides by. Both sides by 8/1. We will never flip this number right here. That number doesn't get flipped. What gets flipped? Now, why do we do that? Well, to get rid of multiplication, you divide. We divide by a fraction 1/8. That's what we have to do the copy dot flip with. Okay? What happens on the left side? Danny, on the left side, what happens? Over here? We did all that, but what happens when we do? What's 8 divided by 8? Everything cancels on the left side, and you're just left with x. On the right side, Laura, what do we got to do with 7? Does anything cross reduce on this one? No, so you got to multiply straight across. 7 times 8? 1 times 1. And what's 56 divided by 1?
56.
So the final answer is?
X equals 56.
Danny?
If it's something that's not under 1, you have to reduce it.
So most of the ones for homework look like this, but you could have on the other side, you could have 2/3.
One of them I got like 40 over 2. So
Yeah, reduce. Yeah. All right. Let's do another one, box 8. Box 8. Nathan? Okay, here we go. Hey, what's attached to x, a decimal or a fraction? So what are we going to do with that fraction? Flip it. Multiply both sides for that. Turns out it turns into a big, fat 24. All right, e-learners. Anyone? Questions? No e-learners present. If you have any questions, e-learners, send me an email. We will see you tomorrow.
We never see them.